One of the viewers of the last video I recorded asked, "Where is the mic?" Well, if you're watching this video, thank you. And here is the mic. Now, let us understand what a data structure really is, and let's do that with the help of a story. This is you. You are at home enjoying the festive break, homemade food and family time, but the holiday will be over today and tomorrow you will head back to college.
The next day.
You reach the railway station and you see that your train pulled in. You realize that the coach in which your seat is reserved is way behind, so you just hop on the compartment in front of you. As all of the compartments are connected, you walk through them until you reach your seat. After a few hours of journey, you have reached your college. Once at college, you meet your friends. You saw another group of people nearby who you know, so you wave them hello and chit chatted with them for some time. The journey has made you hungry and it is lunchtime anyway, so you decide to head to the canteen. When you reach the canteen, you see a big line of students waiting. You join the queue and patiently wait for your turn. When you reach the counter, you grab a plate from the top of the pile of plate, you fill it up and dive into lunch. After eating, you check your weekly planner to see what classes you have next. Lunchtime is from 2 pm to 3 pm and it is Monday, so you check 3 pm to 4 pm slot. It is open, but from 4 pm to 5 pm, you have data structures and your HOD is teaching that one. Being the responsible student that you are, you decide to prep for the class. So, you head to the library to borrow the Introduction to Data Structures book. Since books in the library are arranged by their initials, you go straight to the rack labeled I. You pick the book and occupy one of the vacant seats. You flip through the books for a while and then, when it is time, you walk to the class. The lecture is great and everything taught just clicks. By the end of the day, you realize something. Long before your professor explained what a data structure is, you had been using them all day. In train, when meeting your friends, the line at the canteen, the pile of plates, the weekly planner, and the library. You had been living with data structures without even knowing it. Let us see how. For that, let us take a closer look at your day. Your journey started at the train station. Since your coach was far back, you boarded the compartment right in front of you and you walked through the connected coaches to reach your seat. This is similar to a linked list where each node links to the next one. If you have to move, you move forward one by one. You can also easily add a node or remove an existing one. And the removal or addition is done by adjusting the links. Linked lists are perfect when you need easy insertion or deletion, but it is not suitable if you need an instant access to a specific node, as you would have to walk through in order to reach the node you want to access. Think of your group of friends. Your friends knows each other well. Some only know you, and some are friends with people in other group. This web of friends and connections is what a graph looks like. A graph helps you model connection between things. Each person is a node, also called vertex, and each friendship is a link, also called an edge. When your data is all about relationships, like friends or cities linked by roads, a graph lets you easily see who is connected to whom and how can you move from one point to the other. At the canteen, you join the lunch queue. Here, the first to arrive is the first served. This is called FIFO, first in, first out. You can add to the end, also called NQ, and remove from the front, also called DQ. Queues are excellent for serving processes strictly by their arrival order. That is, the one who comes first will be the one to be served or processed first, like ticket counters or line in canteens. When you reach the counter, you grab the top plate of the pile. Here, the plates placed last will be taken out first. This is called LIFO or last in, first out. You can add, also called push, and remove, also called pop, at the top only. You cannot access a plate in the middle of the stack. Stacks are great when you only need the latest item. For example, the undo operation in applications. Your weekly planner shows each class in a fixed slot and they are arranged by day and hour. This is like a 2D array where data is organized in rows and columns. Here, days form the rows and hours form the columns. If you think of the schedule of just one day, you can access any class directly by the position in the array. You can also update it easily. An array works well for a simple sequence of data. In this weekly planner or weekly timetable, you can access any slot by specifying the day, for example, Monday, and the hour, for example, 4 to 5 pm, and that will give you DSA. This grid like structure makes it easy to organize the data that has two dimensions, like a timetable with days and times. An array is an excellent choice when you know the total number of items in advance and you want quick and direct access to any slot. Your department could be structured like this. At the top is the HOD or the head of department, the person responsible for academic and administrative leadership. Reporting to the HOD are professors, who are senior faculty members specializing in different subjects. Alongside them are associate professors. The department also has lab instructors who handle practical labs and equipment, and the administrative support comes from the department's office staff, handling student records, scheduling, and communications. This hierarchy branches naturally, showing a tree structure where each node is connected to their superior or subordinate node. Visiting all of the nodes is called traversal. Traversing the tree can represent navigating from HOD to individual instructors or vice versa. Trees are excellent for organizing hierarchical data like folder structure, department charts, or family trees. At the library, you knew that all the books were arranged in rack by their title. So you went straight to the rack labeled I when you were looking for Introduction to Data Structures. Hash table store the data by mapping a key to its value, and hence we can retrieve a value by using the key. In our case, in the example of library, the key was the book initial, which was I, and the value was the book location. This mapping helped us get the book instantly without checking for every shelf for the book that we wanted. Hash tables make the insert, search, and remove operations very fast. They are best when you need rapid access by unique keys, for example, book title or username or IDs, etc. If instead of using the book initials to search for the book, you would have searched for each and every shelf, it would have taken a lot longer. So, to answer what data structure really is, according to Wikipedia, a data structure is a data organization and storage format that is usually chosen for efficient access to data. Data structures might sound intimidating, but when you look around, they are everywhere. Understanding data structures is important because understanding it means understanding how computers organize data efficiently. And organizing data efficiently is required for better performance, quicker decisions, and smoother applications. That is all for this video. I hope I've been able to teach you something useful. If you have any suggestions, feedback, or queries, feel free to put them in the comments. Thank you for watching. I'll see you in the next one.